Okay, so another straightforward theoretical one. So they are asking what is false about aluminium. So aluminium compounds are used as catalysts. So many Al2O3, if you remember what the dehydration of alcohols, you can use Kong sulfuric or either aluminium chloride. Okay, here to see. And aluminium metal reacts with dilute HCl and form H2 gas. So I think we have discussed this in the previous structured essay. One of the, in fact, it is structured essay. Yeah, it was structured essay if I can remember. We have to find the metal. We found that is aluminium. So aluminium is amphoteric. So as I told you before in the previous class, it will react with HCl to form AlCl3 and H2 basically. Okay, and also it will be reacting with NaOH to form sodium aluminate, which is NaAlO2. Okay, so don't forget about that. This can react with either acid or base. And the solution formed in solid aluminium chloride AlCl3 is dissolved in water is basic. So this is wrong, because if you can remember, we discussed this aluminium aqueous complex in water will be Al H2O 6 3 plus, or either Al, I told you this can be OH, and there can be like H2O, 5 H2Os in fact. Okay. 2 plus. So these two can be present in the aqueous solution. So what is happening here? One of H2O molecules here have become OH minus, which means they have removed H plus here primarily. Okay. So giving H plus means what's its activity, or what is its act? This aqueous solution of aluminium acts as an acid, which means this solution is more or less little bit acidic. Not like acidic like HClO, HNO3, but it is still little bit acidic. Okay, don't forget about that. The shape around aluminium atoms in solid aluminium chloride is tetrahedral. This is straightforward because you should know. Even though AlCl3 in liquid solution is okay, but when it is in solid, it quickly dimerizes to form Al2Cl6. So I will stop sharing to this to show this structure. Okay, so normally we have this AlCl3, which is typically in this form. For an example, let's say this one. But when it is in solid form, it can quickly dimerizes. So you can imagine what could happen here. There cannot be anything happen in this way. So you can change this one. One of these can be given to this one, and this could be here, and this one. So this is the dimerization that can form. And when it is forming its dimerization, you can see automatically the repulsion unit around aluminium becomes 4. Okay, it's like 4 bonds. So basically, when it is like 4 bonds, its geometry around aluminium is going to be tetrahedral. Okay. Want aluminium hydroxide and HCl form as product of third answer. So what is third answer? The idea is, so you have aluminium chloride. So you dissolved in water. Okay. So what is going to happen here is when you have this aluminium chloride, so you dissolve it in water, so you expect to form aluminium hydroxide. Okay. You expect to form aluminium hydroxide, and you think that HCl is going to form additionally. Okay. The idea here is, think about this HCl that you have here. This is already acidic. Okay. So this will act on these equilibriums because this is always in equilibrium more or less. So this will act on this equilibrium and will shift this towards this left hand side. So more or less you will have this one, which is the aluminium aqueous in the solution. Okay, then its activity is this. So this is the main equilibrium that is present in the solution. This is very poor in water. You can make it happen, this one, a little bit basic condition, because HCl will be removed and more dominant aluminium hydroxide will be there. Okay. So this is it okay? I have to check the chat again. Where is the chat? Okay. And the shape around aluminium atom is solid. This is okay now. So you can understand aluminium dichloride is present in the dimer form in the solid state. Okay. So aluminium dichloride.